Alright, so we are in Algebra 1, Lesson 9-5, Factoring the Greatest Common Factor. Heather's going to make the announcement really quickly, so she's probably going to interrupt, but here we go. It is Friday, March 13th. Oh my god, it's Friday the 13th, everyone! That's why it smelled bad!
Yeah. Alright. Now negative things are going to happen for the rest of the day.
Good morning, everyone. There is a menu change today, if you did not notice on the announcements. Breakfast will be cereal, and lunch will be tuna with crackers in a sack lunch because Miss Wesley is not here today. Thank you.
That makes sense. Thank you, whoever handed out the cards. Was it you, Charles? No? Who handed out the cards? Thank you, whoever did that. Oh, that worked out really well. Our objective Aurelio, I don't know, like, you cannot ever keep anything in your desk again. Thank you for that.
Sorry.
They were so, well, Heather's them too. They're
Jerry's regretful. I guess I'm sorry. Your mind is confused. I just don't want to.
Was it open?
Well, we were like, it smells like so gross over here, and then Emily opens up like, oh, and everyone just like cleared out. Yeah, Charles.
Were we doing the warm-up or not?
Oh shoot. The warm-up was to just do the survey. Yeah, because we didn't have enough time to do everything. Our objective today is to Emma.
Factor out the greatest common factor, coefficient, and variable of any polynomial.
There it is. Yeah, so there's actually two steps whenever you're doing the greatest common factor. You guys know greatest common factor really well. You probably don't know that though. Whenever we had a fraction like this is going to be 6/8 and you need to reduce, you're like, oh, what should I divide the top and bottom by? Everyone's like, oh, very clearly we should divide the top and bottom by 2. 2 is the greatest common factor. So if you know how to simplify a fraction, you should know how to find the greatest common factor. And if again, if you had like a bigger number, like 120 over 360, 120. What's up? Why? Oh, okay. If I had a bigger number, 120 over 360, the answer, like, what is the easiest way to simplify this? You'd say, oh, just divide the top and bottom by 120, and therefore you'd be finding the greatest common factor because 120 times 3 is 360. This reduces to a third. So the greatest common factor is the one number that you would divide by in order to simplify that fraction. All right, so let's start with some vocab. What is distribute? Let's just do it with a picture. So if I have, for example, I don't know, something that looks like this, where I have, 3x times 2x minus 1. What is the picture that we do in order to distribute? Yeah, Kira?
You put the little arrows over top, you point the 3 into the 2x and the 3 into the negative 1.
Exactly. It's another word for really advanced multiplication. So factoring, it's almost exactly like that, yeah. In fact, if you want to write that down, you can. That's a good definition. I'm going to write it down as undoing, or undistributing, I think would be. You can say undoing distribution, or you can say undistributing. It's going backwards. So if I had, 6x squared minus 3x, this will turn into, okay, what is the greatest common factor? And it will turn back into this thing. I say, well, the greatest common factor between 6 and 3 is 3, and the greatest common factor between x squared and x is x. And I factor out the 3x, and I'm left with 2x minus 1. It's undoing all that stuff. And if you don't know how to get all of this stuff yet, I will teach you. That is all of today's lesson. If you understood this example perfectly, you don't need to do today's lesson. Why?
He just went to the office because he was feeling really sick.
Okay, thank you for letting me know. All right, so the greatest common factor. What is that thing? I'm looking for a size word here and an operation word here. Few people. Anyone that has their card? Charles?
The biggest factor that multiplies both numbers.
That not multiplies, but
Divides.
divides, yes. For example, in that 6x squared and negative 3x, the thing that I could divide both of them by. I could divide this 6x squared by 3x. I could divide this negative 3x by 3x, and therefore 3x was the biggest common factor. Or the greatest common factor. No, I said greatest. Biggest, greatest, same word. All right, so there's always going to be 2 steps, and I'm slightly lying to you. I'm oversimplifying it, but there's 2 steps when you're factoring. And when you hit Algebra 2, you'll discover how in-depth I'm lying to you. But step 1, or step 0 if you want to call it, with your computer science. Step 1 is GCF. And I'm very simplifying is I should be writing out, you need to factor out the GCF. No, it's just get rid of the GCF, factor that out, and then finally step 2, which we're going to be learning on Monday, Ninja Star. Always, always check the greatest common factor. Cohen, do you know why we're lying already? Cohen's like, there's an advanced Ninja Star. Yeah. Yes, there is, and I'll eventually be teaching you guys that one as well. Other things that I wanted to say about this? No, I think that's it. Okay, so there's always 2 steps for greatest common factor. So I'm only on step 1 right now. I'm only talking about this greatest common factor. And that greatest common factor has 2 parts to it. So here we go. It has a coefficient and a variable for every single term. For example, if I had an 8x to the power 4 and 4x to the power 6, those are 2 terms. I talk about their coefficients, 8 and 4, and I talk about their variables, x to the power 4 and x to the power 6. So there's 2 components that I look at. First, let's look at the coefficients. The coefficient, you know how to do, it's just the greatest common factor as you've been doing. So it's just GCF. And that's not the most explanatory, but if I had, I don't know, 10 and 5, the greatest common factor of that would be 5. What's the biggest thing that I can divide both of them by? To reduce that fraction, maybe if I had the fraction 10/5 or 5/10, I would divide the top and bottom by 5. All right, are you okay, Eamon? Okay, or Monday. All right, and then for the variable, you are going to be finding the smallest power. And if you don't like the word power, you can use the word degree too. That'll work just as well. What do I mean by that? So let's say I had x times x times x times x. So I have 4 x's there, and I was adding x times, or x plus x. X times x. Again, I'm trying to think of what is the greatest common factor of these. Well, I have 2 x's there, and I have another 2 x's there, so the greatest common factor is 2 x's there. So it's the same thing if I said 2 times 2 versus 2 times 2 times 2 times 2, and I ran out of room there. 2 times 2 is 4, and 2 times 2 times 2, all 4 of these is 16. What's the greatest common factor between 4 and 16? It is whatever that is because it has the least number. So the greatest common factor of these 2 is this x times x. X is just a number, right? I could have made it 2, so I made it 2 for a very simple case. The greatest common factor will always be the fewest number of those. So that's why I'm saying the smallest power. Really what I'm saying here, x times x times x times x is really what? X to the power of, quiet raised hand, Esha?
4.
Yeah. And then this other one, Esha, is, or sorry, this is 4, and then
That's 4, and the other one's 2.
x to the power of 2, thank you. Which means I'm really looking at this smallest power 2, and I'm saying, hey, this x squared is my greatest common factor.
Why?
Good questions, good questions. I'm trying to explain the why as best as I can. When you're dealing with polynomials, they're just numbers. Like this is 2 or it's 3. These are the same number repeated. So if I did an example with 3 times 3 versus 3 times 3 times 3 times 3, well, 1 is 4, 1 is 16. The greatest common factor between 4 and 16 is 4, because 4 goes into 16. X and x go into x and x. This x and x and this x and x are the same. I just have a leftover of these 2 x's. Greatest common factor is just pulling the same thing from both of them. What similarity do they have? Well, this has a similarity of x and x. So far, x and x as well. When I take those away, I'm still left with 2 that I didn't take. I'm trying. I don't know the best way to explain this. That's what I've got.
How about we just do it in
Let's
go?
let's practice and see if it doesn't make sense still by the end of the lesson. You have another way of explaining it?
No, can I do?
Oh, you're ready to go for it already. Yes, Charles. Is that your second card that you're using now? Okay, fine. Go for it.
Okay, fine.
It would be 4x squared.
Ooh, 4x. But what's the smallest between 4 and 6?
Oh,
4x to the power 4. Done.
so why wouldn't it be
What?
4x squared?
Why isn't that squared? Because I can take away, like this is just listing out x times x times x times x. There's 4x's there. This one is x times x times x times x times x times x. There's 6 x's. How many can I cross off of both of them? I can cross off 4 and I can cross off 4. I can't cross off 5. I could cross off 2 and 2, but I can still cross off more. I can cross off another one. I can cross off another one. And I'm trying to balance these. I'm trying to reduce them if you're thinking of them as fractions.
So it,
We'll go with Charles again, and then Kira, and then Jade.
Don't you, like, isn't it like you divide it by 6 is indivisible by 4?
So remember that when we're dealing with exponents, when we're dividing, we're really saying subtracting. What's the biggest number that I can subtract from 6? Well, I can subtract 4. What's the biggest number I can subtract from 4?
Okay, that
4.
makes sense.
Yeah, Kira.
that's. I thought greatest common factor was like if you had 16 and 4, you divided both of them by 4, and you'd end up with 4. But that's not what you just did.
So it is, but it's using rules of exponents. So let me show you basically the same type of thing that I said in words to Charles. Why is this not working? There it goes. So if I have, for example, let's treat this as a fraction, right? Let's zoom in here. I have 4x to the power of 6 over 8x to the power of 4. I'm going to divide the top by, let's just do 4x to the power of 2 and divide by 4x to the power of 2 and see what happens. If I divide 4 by 4, I'm left with 1, so I'll just write 1. If I divide 8 by 4, I'm left with 2. But now I have to divide these. X to the power of 6 divided by x to the power of 2. When I do that as a side problem, x to the power of 6 divided by x to the power of 2, remember that division, when I have the same base, these are both x. When I have the same base, I'm doing 6 minus 2, and this is turning into x to the power of 4. So my answer here would be, when I do x to the power of 6 divided by x to the power of 2, I'm left with x to the power of 4. And similarly, I'm going to subtract 4 and 2 to get x to the power of 2. Well, I could have simplified even more. I could have subtracted, because that's what we're really doing here, 6 minus 2. I could have subtracted even more. I could subtract another 2. So I'd have to divide again by x squared to subtract 2 more to get rid of these x's, because x squared divided by x squared is just 1. These go away, and this is left with x squared on the top, because 4 minus 2 is 2. I'm still with Kira.
So, how did you get a 4 though? It's 4x to the 4th. I get how you get the exponent, but I don't get how you got a 4 as your answer. If 8 divided by 4 is 2. Or, wait,
So the coefficient or the power? Oh,
the coefficient.
this coefficient right here, 4?
Yeah, you were just dividing 4 by 8, and I don't think the answer is 4.
Okay, so let's treat it as a different problem. What if instead, okay, so I'm just looking at the coefficients, 8 and 4. Let me turn that into a fraction. If I had 4 over 8, what would I divide the top and bottom by to reduce that fraction? 4. 4 is the greatest common factor between 4 and 8. So the greatest common factor between these coefficients, 4 and 8, is 4, and that's why I'm writing down 4.
Oh, you're just finding. Oh, you're not like doing the problem. You're just finding the greatest.
I'm just finding the greatest common factor, which is going to help us to solve the problem in a sec. We haven't factored anything yet. I'm just finding the greatest common factor. Who is next? Was it Wyatt?
That was Jade.
Jade?
But that's the same question I had.
Okay. Did it clarify for you though?
Yes.
Okay. Then Wyatt?
So you're just finding for the coefficients the GCF, which is 4 in this case. And then basically you're just taking the smallest power from the variable, which is also the exponent, so it would be x to 4, which is your final answer. That's just what you're doing.
Yes. Question, Emma.
So why would you subtract the exponents?
So that's just one of the rules of exponents, and it's, what unit was it? Was it unit 7 or 6? Where the rule was if I have x to the power of a divided by x to the power of b, this is equal to x to the power of a minus b. And the rationale for that is just cross-canceling. So if I have, for example, I have 2 x's up there and 1 x down there. So if I have x and x on the top and x on the bottom, how many can I cancel? Well, I had 2 x's on the top. I can cross-cancel these two because it's the same thing. If I have the same thing on the top and bottom, I could just cross them off. And this is saying, oh, that's equal to x to the power of 1. Well, what did we really do? I had x to the power of 2, and I am going to be dividing by x to the power of 1. I really subtracted 2 minus 1 to get that. All right. These are great questions. I've never had a class that asked such good questions on this lesson, or most of my lessons for that matter either. But this is making me much more confident that you guys know what you're talking about. All right, I'll close example 1 by saying I'm really looking in terms of 8x to the power of 4 and 4x to the power of 6. What is the biggest number I can divide these coefficients by? And what is the biggest number that I can subtract from both of these exponents? Because one is division, one is subtraction, which is really division, but just with rules of exponents. Esha.
Can I take a guess at example 2?
You may,
Or
yeah.
I tried to do it. But
Go
I
for it.
wasn't doing it right.
Yeah.
I got 3y to the power of 8.
You're so close. 3y to the power of 8. I'm going to write it here. There's one mistake.
Probably the 3.
It is indeed the 3. What should it be?
Well, I guess it could be 9.
It is indeed 9. Why is it 9?
Because 9 can go into 9, and 9 can also go into 36.
Perfect answer. There it is. Yeah. Well, yeah, you can do the next one. But before you do it, are there any questions on example number 2?
Well, I have a question on this.
Okay, I can't do that quite yet, Charles. I have to do the notes first. All right. Yeah, so we haven't done a factoring problem. We haven't actually done, well, actually, sometimes Khan Academy does just ask for the GCF. But normally we're going to be doing distribution and factoring. So I'm going back to the first half of Unit 9, distributing. And that's what you're doing, right?
Yeah.
All right, what do you want to do?
So I was gonna distribute it first.
Go for it.
So 3x to the power of 2 times 4x to the power of 3 would be 12x to the power of 5. Plus, so 2 times 3x to the power of 2 is really 2x to the power of 0. So it would be plus 6x squared.
So, Mr. Snow,
Yes.
kind of wasn't paying attention when you got 9. I wanted 8.
Okay, yeah. Who can re-explain where this came from? Kira, go for it.
So 36 and 9. 36 divided by 9 is 4, so 9 is the greatest common factor of those two, and so that's why you put 9 there.
Another way of saying it is I can divide that by 9 and get a whole number. I can divide that by 9, 1 is a whole number. So keep going.
What about the exponents?
Okay, and 8 is the smaller exponent, so, yeah.
Just
But-
choose the smallest one.
Actually, now I'm confused. On the last one, you subtracted 4 from 6, right?
Yes.
But on this one, you didn't do that.
This was just showing you what the greatest common factor is. Another way I know that you guys are really good at reducing fractions, so I use reducing fractions because greatest common factor is a tool to reduce fractions. When we actually reduce the fractions, we did subtract. And that's essentially the question I'm asking. What should I subtract? I'm not doing the subtraction yet. What should I subtract? I should subtract a 4. That's the biggest thing that I'm allowed to subtract from here and here. All of this, I normally don't have the notes. This is just a way to explain how GCF is used as a tool. We're about to use the tool right here, down here at Factory. Question, Jade.
So, let's say it was 36 and 10 instead of 36 and 9.
Okay.
How would that work?
Okay, what's the greatest common factor of 36 and 10? Say it louder. 2. Yeah, so it would be a 2 up front.
Oh.
And it would still be y to the power of 8 because those haven't changed.
Okay.
Yeah.
So it could work. So that's kind of
Any number, yeah. So give me 2 round numbers. I'll tell you what the greatest common factor is. Ready to go.
101,000,003.
Oh, dang it. Okay, give me a 2-digit number and I can tell you better.
92.
92, okay. And
20.
and 20. All right, Greystone Factor's 2.
What about?
Oh, no, it's 4. Dang it.
Mr. Central.
4, because how do I know if I do 80? 80 is divisible by 4, so that remainder of 12 and 12 is also divisible by 4. So 4 is the greatest common factor between 92 and 20. So it'd be 4, and then this was x to the power of 10, and x to the power of 99. This would be x to the power of
10.
Yeah, we just choose the smallest one.
So this is like just writing down the tools, like the things that you're gonna be subtracting.
We haven't even used our tools yet, which is what we're going to be doing
So
now.
can I also do that with example? Like something similar to what we did?
Yeah, exactly. Yeah, just change these numbers. What number goes to both of them? What can I divide both of them by? I have 5 more minutes. We have to kind of rush now. Sorry, guys. So, when we did this, we did what with the exponents or the coefficients? 3 and what did we do to get 12? Shout it out. We're just shouting them out from here on out. Multiply. Everyone write down multiply. What about the exponents? I had 2 and 3 and I somehow got 5. What operation do we do to 2 and 3 to get 5?
Addition.
Addition, add or addition, either one works. So now we're going to flip that. What's the inverse operation for multiply coefficients? It should now be divide them. And again, I love the quiet raised hands. We're going to go fast and furious. Just shout them out for the remainder of today, but we'll go back on Monday to raising their hand. The opposite of add, everyone will shout out. Subtract. All right, so first you find your greatest common factor. That's step 1, and that's kind of a hard thing to do. Once you find the greatest common factor, then you factor that out. So between 12 and 6, what is the greatest common factor of those coefficients? You guys will shout out 6.
6.
Between x to the power of 5 and x to the power of 2, the greatest common factor is
X2.
x to the power of the smallest one, 2. Because again, the question is always, what's the biggest thing I can subtract? Well, I can't subtract 3 because then it would be a negative. I can only subtract 2. So 6x squared is the greatest common factor. Label this in our notes. That's the GCF right here. We found it. Now we're going to use that tool, use the fact that it's the greatest common factor, and factor that out. So on the inside, I should have 2 terms. Terms, by definition, have a plus or minus sign in between them. I'm going to copy down the fact that I have a plus sign in between them right here. Okay, I'm going to use what you just told me right here. I'm going to divide the coefficients. I had 12, a coefficient, and I'm going to divide it by 6, and I'm left with, you guys will shout out.
2x to the power of 3.
You're so fast. I'm doing the coefficients right now. And then the exponents, as Wyatt has already done for us. I have x to the power of 5. I'm going to subtract the exponents. 5 minus 2, and you guys will all shout out x to the power of
3.
Try the next one. I'll give you guys 5 seconds.
Done.
Dang it. 5 seconds. I have 6x squared divided by 6x squared. And you guys will shout out
1.
1. Or 1x to the power of 0, right? Because 2 minus 2 is 0, and x to the power of 0 is just 1, so you can kind of scribble out the x to the power of 0 and just say 1. That is the way that you factor it. You have done your first factoring problem. 12x to the power of 5 plus 6x squared is 6x squared times the quantity of 2x to the power of 3 plus 1. All right, so do example 3, 4, 5, and 6 on your own. I will finish the video on my own time. You guys have about a minute and a half left of class. I will give you a hint. One of these cannot be factored. And if that's your question, Charles,
That is my question.
was it number 6?
It was number 5 and 6. Actually.
5 can be factored.
Okay.
It can. 6 cannot. Can everyone just jump down? I don't want anyone to be too confused. This one cannot be factored. I was hoping that we could get to it, and then we would all struggle and be like, I'm pulling out my hair. How can I do this? You can't. There's nothing you can do.
Is it 1.5 here or 15?
I'm going to silently write all the answers up here, so let me do this one right now. So what number goes into 30, 60, and 100? So greatest common factor of 3 terms. The answer is 10.
Oh, because it can't be 1. Oh, I'm
No, you're good. You're good. Like, you just
I
haven't seen
didn't
it
see
before.
that.
And then I'm looking for the smallest between 34, 33, and 32, and the answer is 32. So that is the GCF.
And then we have the
30 divided by 10. 3. 34 minus 32 is 2. C to the power of 2. 60 divided by 10 is 6. So plus 6. I'm copying down the signs in between. Always copy down the signs. And then 33 minus 32 is 1. So C to the power of 1, which is just C. And then negative 100 divided by 10 is negative 10. 32 minus 32, 0. So I could say c to the power of 0 or just cancel it out altogether and say just negative 10.
And that's what you're going to put into Khan Academy.
That is exactly what you're going to type in verbatim into Khan Academy. And they don't like it when you do a power of 1 or a power of 0, so simplify it. That's how it's in simplified form. What about this one? Greatest common factor of 35 and 20 is 5. Greatest common factor here and here, well, I choose the smallest one, it's 100. So b to the power of 100. The bell should ring in about 2 seconds. When I divide 35 by 5, I get 7. You guys are dismissed. When I do 102 minus 100, I get b to the power of 2. Copy down the sign. It's a minus sign. 20 divided by 5 is 4. Subtract, nothing. And then finally, greatest common factor is 2a to the power of 4, and that's going to be factored out, and it's going to be 6 divided by 2, 3. This is going to be nothing. Plus, 8 divided by 4 is, or 8 divided by 2 is 4. 7 minus 4 is 3. 8 to the power of 3. And I'll have these notes online for you guys.